Hello, welcome back to my channel. So I'll be going over some examples on solubility curves, how to read it, and how to answer some of these different types of questions. So this is just some sample questions, and I also have this solubility curve. So this is what this graph is called, and it's actually double-sided. So we'll may have to go back and forth depending on the line that we have to use, and basically and that'll help us answer these questions here. So before we get right into it, what this graph is, again, it is called the solubility curve. And essentially what this means that you have different solutes of, different solutions that is in 100 grams of water. And it has different solubility rates because, as you can see here, there's some graphs that go kind of steady, or there's some lines that go like a steep slope or very, very flat. It all depends on the rate of solubility because there are some solutes that dissolve faster or dissolve slower than others, so that's why the lines are different. And same thing on this side, as you can see here, like potassium nitrate here, KNO3, it has a very steep slope, like exponential growth, so that just tells you that it dissolves a lot quicker than the rest of these solutes here. And as you can see here, sodium chloride, it has a pretty straight line, so it doesn't matter what temperature it is. It kind of dissolves the same way in different temperatures. Okay, so we're just going to go ahead and start with the first question and hopefully break down the graph as we go. Alright, so I'm going to try to do a different color for each one so I can actually pinpoint on the graph here. Alright, so how many grams of KNO3, so potassium nitrate, will dissolve in 100 grams of water at 50 degrees Celsius? So first off, you may see a little pattern here in all these questions. So you may see a lot of 100 grams of water, 100 grams of water, right? So the 100 grams of water just tells you how much solvent you have. So again, remember, solvent is what you use to help dissolve the thing that you're putting in. So if you see here, the y-axis here is per 100 grams of water. Again, so think of it as a beaker of water that you put stuff in it to dissolve, right? And so that's the standard. This is our graph here. That's always out of 100 grams of water. So whenever you read a question like this that will dissolve in 100 grams of water, just think of it as in a beaker of water at this temperature. So all you have to do is find the temperature, which is my x-axis, and you're going to figure out where is it at in the graph where it dissolves. Okay, so I have 50 degrees Celsius, but I go up, find KNO3, so potassium nitrate's line's right here, and it falls on this line, and that is 80 grams. So the answer here is 80 grams. What this means is that I can put 80 grams of potassium nitrate in 100 grams of water at this temperature for it to be like a perfect solution, a saturated solution. Okay, so if I put less than 80 grams, which means it's going to be like a watery, dilute solution. If I put more than 80 grams, it's going to be too much. It's going to be super saturated, like overly concentrated of the potassium nitrate solution. Okay, so that's the first question. All right, so for number 2, now it's asking for temperature instead of grams. So at what temperature will 100 grams of KBr will dissolve in 100 grams of water? All right, so KBr is actually on this side of the graph. Okay, and so I'm going to find the grams of KBr. So again, grams are in the y-axis. So if it helps, maybe you can write this as an extra note for yourself. So x-axis is your temperature. I'm abbreviating. Your y-axis is your mass. So that way when you're trying to find grams, you look at the y-axis. I've had several students make that mistake and find it on the x-axis, which is wrong. So I'm going to find 100 grams right here, and now I'm going to try to find KBr on the line right here. So it's roughly, I say roughly 95. As long as you're close, it's fine. So 95 degrees Celsius. Okay. Great. Okay, so for this next question here, how many grams of KBr are needed to saturate 200 grams of water at 10 degrees? So notice here, now I've got 200 grams of water instead of 100 grams. I'm going to try to like squiggle it so that way it's important. Whatever. So this is why I don't want to say that the 100 grams of water is irrelevant or ignore it. It's actually pretty important to recognize that if you have to scale it or not. So over here it says 200 grams of water, but in my standard graph I have 100 grams of water. So the 100 grams of water, that is half of 200. So if I half the 200 of water, I have to half the temperature. So I'm just going to make this note here. I'm going to look for 5 degrees Celsius on the graph instead of 10. Okay, so 5 degrees. I'm going to go up to the line of KBR, and that's roughly 55 grams. Okay, so here's another way you can work this out when it comes to scaling it. So according to the question, I have 10 degrees Celsius per 200 grams. However, to scale it, I have 100 grams from the graph, from the solubility curve, so I just need to half it. So 200 divided by 2, 100. 10 divided by 2, 5. And that's what we're looking for. Alright? Alright, perfect. So, for this next question, if a solution of sodium chlorate with a concentration of 140 grams dissolved in 100 grams of water, so notice that 100 grams of water. So whatever says 100 grams, just ignore it because it does match the solubility curve. At 55 degrees Celsius, is the solution saturated, unsaturated, or supersaturated? So whenever you have these terms here, that's when you are given the grams and the temperature. And you're going to pinpoint it on the graph and kind of compare it to the saturation. So as a reminder, saturated, and I'm going to abbreviate, saturated means on the line. That's when it's perfect. It has the perfect amount of solute in water. Unsaturated is under the line. Under the line, so it makes it unsaturated under the line. So that's when you have less than the amount that you need. So that's when like more of a dilute, watered down solution. Then you have supersaturated. So I hope you get to see the pattern that I'm doing here. Supersaturated is when you have over the line, too much. Alright, so think of Kool-Aid, for example. You have some water, and let's say you have like a big jug of water, but you only put a tiny spoon of Kool-Aid in it. It's still going to taste like water because the water can still hold more of that Kool-Aid. So that would be unsaturated, when it's way too little. Okay? Saturated is when you have the perfect amount of Kool-Aid, right? It can't hold any more, but it can't hold anymore, but like you shouldn't lose anymore because it's the perfect amount of concentration. And then supersaturated is, again, when you have too much. That's when the Kool-Aid is way too sweet. That's when the Kool-Aid, some of it is settling at the bottom and it's not dissolving. That would be supersaturated. Okay? So, how we figure this out? Now that we have the on the line, under the line, over the line, now we're going to figure this out in the graph. Okay? So we have sodium chlorate, which is this line here. We have 55 degrees Celsius, 140 grams. So I'm going to go ahead and find that on, so 55 degrees Celsius, 140 grams. When I pinpoint that on the graph, it's right here. Okay? And we're going to compare that to this line here. So sodium chlorate, as we can see, it is over the line. So it is too much at this temperature. So since it's over the line, it is supersaturated. Now, I know it's not written on here, but what if I ask you, now that we know that it's supersaturated, what if I ask you how much extra of the solute is there? So how would you do that? So you basically just find the difference between like this space and where it's saturated. So here we have 140 grams, but when is it saturated? When is it on the line at this temperature? Around 130. So 130 versus 140, I have a 10 gram difference. So basically I have 10 grams more than I need to make the perfect sodium chlorate. Okay? So I hope it's making better sense. All right, so I'm going to skip over to, let's say, so these are pretty much the same type of questions. Actually, let me go over this question, because it's a little different, but same rules apply. All right, so you have 100 grams of water. Again, got that same standard water. At 90 degrees Celsius has 40 grams of NH4C, so ammonium chloride. So that would be this side here. By the way, you'll always be given a solubility rule, solubility graph, or solubility curve. There's different words for it. You'll always be given this, and it typically looks the same thing. Okay, so you're trying to find ammonium chloride. How many grams of ammonium chloride would need to be added to the solution for it to be saturated? So it's kind of opposite of what I answered here. So let's go ahead and find the ammonium chloride here. So this is this line over here. We have 9 degrees, and we have 40 grams. So when we pinpoint that, it is over here, right? And it's clearly unsaturated because it's under the line. So that's not what it's asking, because the question already knows it's unsaturated. It's asking how much do I need more to add for it to be saturated. So all we need to do is count from here to here. Okay, so 40 grams here, and then for it to be saturated, it's 70 grams. So 70 grams versus 40, the difference for that would be 30. So that is the answer for number 7? Whatever this question is. But yeah, this question would be 30 grams more. All right. Cool. So last but not least, I'm going to do this last question. I'm going to try to make it less than the 15-minute mark. So a saturated solution of sodium chlorate, again, we're going to do this curve right here, is formed from 100 grams of water, again, with that water again. If the saturated solution is cooled from 80 degrees to 60 degrees, how many grams of precipitant are formed? So again, as a reminder, precipitant is solid, I'm going to say insoluble solid, so that's not dissolved. So what it's asking is that you have a saturated solution, so a perfect solution of sodium chlorate at this temperature, but how many grams of sodium chlorate does, it settles at the bottom if I, cool it to 60 degrees? Because remember, when you increase the temperature, it dissolves more. But when you decrease the temperature, it dissolves less. So it actually forms a precipitate, and like the solute kind of settles at the bottom of the solution, it doesn't really dissolve. Okay, so I'm going to start with 80 degrees. And then I'm going to go up to the line right here. And I'm not perfect, but I'm going to say it's about 165. Okay, so that's for 80 degrees. And then 60 degrees, I'm going to go up to the line here. And I'm going to say it's around 135. So it starts with 165 grams. And then when I cool it to 60 degrees, it gets to 135 grams of solubility. So that means the difference between that is 30 grams. So this is at 30 grams that is precipitating, thus forming at the end of the solution. At the bottom of the solution, that's settling at the bottom. So that's how you would answer this question. Okay, so this is pretty much what I'd like to cover. So the rest of the questions are pretty similar to what I just answered. So I hope this helps. Let me know if you have any questions, and I hope you have a wonderful day.